Thank you all for joining this class. Let's have a short prayer as we start. Father, I thank you this evening for giving us the grace and opportunity to have this class. As I take my student through, I pray for your divine guidance. You will help each and every one of them to fully comprehend the subject. Bless you for prayer answered in Jesus' name. Amen. Thank you. All right, so now we're going to look at the development of a cone, right? And the development of the surface of a cone is a sector of a circle, okay? So when you develop the lateral surface of the cone, what you get is a sector of a circle. The radius um, for the that sector is equal to the length. The radius of the sector of the circle is equal to the uh, length of the slanted edge of the cone. All right, then the we can calculate the angle of the sector of the cone by the formula r divided by x times 360 degrees. All right, and the slanted edge, the true length of the slanted edge is the s, whilst the r is the radius for the circle. So this one, for instance, the true length of the slanted um, area of the cone, right? So when we obtain the front view of the cone, we have the slanted edge of this triangle, which from the front view of the cone, and that slanted edge, the outer one, will give us the true length, which is s, and the radius r is the radius of the base circle. Okay, so if we have the height of this triangle to be 60, which is the height of the cone, and then we also have the base radius, which is in this case 50, and the height is 60. The 50 here is the diameter of the base circle, so it means that from one point here to another point there is 50 millimeters. So if we have the height to be 60 and distance from here to that to be 50, we could determine this edge here by using the calculations, okay? Because we have here, we could use Pythagoras theorem to determine that. So the height and then half of the base diameter, which is the radius, we could determine the slanted edge. And then also by construction, if we draw the front view, the plan, and then the front view, we just measure that distance to be the true length s. Then with that, we use it as the radius, the s as the radius for the sector of a circle, which will be the development of the cone. All right, then the angle that this sector would have will be equal to r divided by s times 360. So r, the radius of the base circle, s, the true length of the slanted edge here, and then 360. So when we calculate that, what we'll get will be the distance, the angle. All right. Okay, so we're going to go into that and see how to go about it. So first of all, we need to draw the projections of the uh, projections of the cone. So we have the plan which is the base circle. Then we have the front view. All right, and the plan, which is the circle, will be having the diameter to be 50. So the radius is 25. So with 25, we draw the circle. Then we can also continue with the front view.
So we first need to draw the projections of the cone, the topographic projections of the cone, which include the plan and the front view. And the front view of a cone is a triangle, and the plan is in the form of a circle. So we draw the circle, which is the base of the circle, the base of the cone. Then from there we draw the front view. All right, so front view, um, we draw it, and to determine the slanted edges of the triangle on the front view, we have to project from the base circle. All right, so project from the base circle. So project that point, and then that side there, this side. So we connect lines to the apex. And remember that from the base of the cone to the apex is 60 millimeters. So the distance should be 60 along the axis of the cone. All right, then after that, we have to divide this base circle into a given number of equal parts. I use 8 equal parts, so I divide the circle into 8. I have the center lines there, which forms 4 divisions, so I divide each of the quadrants into 2. And I use the uh, 45 degrees set square to do that. So with the 45 degrees set square, you draw a line through the center. Right, so use the set square to achieve that. So you can divide it into 8 equal parts. After that, we need to label. We need to label the circle. I mean, each of the generators we have obtained on the circle. So we started from 1 up to 8, and then we label them in the anti-clockwise direction. And this is the base. The apex, we are going to label it O, but the base on the plan should have a reflection on the front view. Okay, so we need to project each of the generators to the front view so that we can have a reflection of that on the front view. Okay, so all these generators we produce should also be on the front view. So we have the 0.8 and 2 to be in line, so we have a projection of that. 4 and 6 will also be in line, so we have a projection of that way. Then from here we can label the base of the cone on the front view. So we label them, and so we are going to have one projection from 1, we call it 1 prime, and then from 2 and 8 we have 2 prime, 8 prime, and then from 4, 6 we have 4 prime, 6 prime, and then we also have 5 prime, and then the center one, 7 and 3, so we have 7 prime, 3 prime. Okay, and then the apex we use O. So on the front view we have O prime, and on the plan is O. Now we connect each of these points to the apex of the um, triangle. Okay, so these are the generators showing on the front view. Then from here, um, we can start with the development. So we first of all, we have to measure. We have to measure the slanted edge. Okay, so the slanted edge here uh, um, will be the outer edge of the front view. That will give you the true shape. Okay, the inner one, the one that we have inside, will not give us the true shape, but the outer one. So measure that distance, which is the true shape. I mean the true length, gives us the true length. Then we use that radius to draw the arc. Then after drawing the arc, we connect the end of the arc to the center of the arc. So the beginning to the center of the arc. Then we need to determine the angle. Okay, the angle. When you open up the cone, we need to have the angle uh, that the cone will make when we develop it. And the formula we use for that is theta equals r over divided by x times 360. Okay, and r, which is the radius of the base circle, is 25. And then the s will be the true length of the slanted side of the cone. Okay, so the true length, we measure that distance, and that will give us 65. So you can put that into the equation, and when you have the angle, which is some value, I think 1 4 something, the angle is 138.5. Okay, so we use that, then we draw the other line. So we have now the area with the through which we're going to have the developed cone. And the next thing is to divide this arc. Okay, that angle we are having, we need to divide it into a given number of equal parts, which should be equal to the number of parts we have divided the base circle of the cone, which is 8. So we need to divide this into 8. And the easiest form is that we use your compass and we bisect. First of all, you bisect the angle made by the cone. So we bisect it that way. So when you bisect, then you're going to have your bisector. So you draw a line from the apex O to the center of the arc to that point. You don't have to extend it to meet the intersecting arcs. Then you bisect again the other one. All right, to bisect again that angle. So now you are having the second bisection of the angle that you obtain. All right, so when you do that, you will then draw another line from the center of the arc to the circumference of the arc that way. Then you do another bisection of the next one. Okay, the next angle again. Then you have a smaller division there. So you draw another one. All right, so this gives us the actual size that we'll obtain in case we divide this arc into 8. So you pick one of the smaller distance there. All right, the smaller arc, pick that with your compass. Then you can mark it along the circumference. So you mark it along the circumference of the arc, all right, to obtain the other divisions which we have not done. You don't have to repeat it for all. If you obtain this small one, then you pick that distance, mark it along the arc. Then when you finish, you draw straight lines from this point to the center of the arc. All right, so we draw the straight line to the center of the arc. Then after that, um, we need to add, let's say, the base of the circle. In case the base is closed, we need to add it. But before that, we have to label the point that we have obtained on the arc. and that depends on how we want to do it. We can depends on where we want to cut the open the cone. All right, so we can decide that we cut it at 1. So in that case we have 1, then 2, 3, 4, 5, 6, 7, 8, and then we end at 1. All right, then we can decide that we want to add the uh, base circle. So if the base is closed, then we need to have a circle at the base, and this circle should touch this arc at a single point. So in this case, if we want it to be at 3, then we draw a circle with radius 25 degrees, sorry, 25 millimeters, touching this arc at point 3. All right, so this is how we go about that. So we draw that base circle. Okay, then we have to divide this circle into the number of uh, parts that we have divided the arc, and we divided the arc into 8. So we have to divide this circle into 8, and then we label all the points over or around the circumference of the circle so that it will correspond with the arc. All right, so we label them. Okay, then the next thing is to um, well, we label, um, draw all the generators. All right, we divide it into 8. So we follow similar principle as we divided the initial one. You can use the 45-degree set square and the 60-degree set square to assist you achieve that. So we have the division done. So we label them. Right, and the labeling should follow in such a way that when everything is put together, it will match. Okay. Now, assuming this cone is truncated, assuming it's truncated by a cutting plane. Okay, and let's say this cutting plane is making an angle of 30 degrees to the horizontal plane, and is cutting the axis of the cone at a distance of 30 millimeters from the base. What do you do? So first of all, we have to draw the cutting plane. Okay, so we measure the distance along the axis of the cone is 30 millimeters. So measure that distance 30 millimeters along the axis of the cone. Then we use you can use your T-square or with the help of your rule line set square or 2 set square. You draw a line inclined at an angle of 30 through the point 30 millimeters from the base. Okay, so we draw the cutting plane, and this is how the cutting plane is drawn. Now that we have drawn it, we need to indicate, because we are removing the top part and the base is what we are dealing with, so we need to indicate, right, so that when we are developing it to be easier for us. So we have to label each of the points where the cutting plane is cutting the generators. All right, those lines we have drawn to the apex of the uh, triangle. Okay, so we label it. The one along 1, we have 1 subscript 1. Then the one along 3 and 2 and 8, we have 2 subscript 1, 8 subscript 1, up to the last one, 5 subscript 1. Then what we will do next is to determine the true length from the apex to each of these points where the cutting plane is cutting the cone. All right, so to do that, we have to first of all draw a line. We project lines from each of these points to the slanted edge, because the slanted edge will give us the true length. Okay, the true length of the lines. So what you do is project special. So the one that are within will not have the true length there if you pick the measurement from the apex. So we have to project them to the slanted edge. All right, so you follow that horizontally, draw lines, horizontal lines from each of those points to the slanted edge. Then with the divider, we pick those points. So you pick them. So from the apex to, let's say, the point 5 subscript 1, you pick that. Then from your developed cone O, you mark a point on 5. You pick that one for 6 and 2. So from O, 6 and 4. So from O, you mark the 4 and then 6. You note those points. Then you pick that one for O prime to the next one, which is 7, 3. All right. So when you come 7, then 3, you mark that point 2. All right. Then um, you have to label them. So we've labeled them, each of them. Then you go to the next one, which is 2 and 8. So from O, you mark 2 and then, sorry, 8 and then 2. Okay. Then you go to the next one, which is the 1 subscript 1. Right. So that's because the one lies on the slanted edge, the outer one, which is the true length. We can use that. We don't have to project to the other side. So just pick that distance, then you mark here and then also mark at that point. So we label them 1 subscript 1, 1 subscript 1. Now you draw a smooth curve through these points. All right. You can use the French curve to help you do that. So you can draw a smooth curve through the points that we have created there. Then after that, we need to firm in the main outlines. So we firm in the main outlines. Okay, so that you have your developed shape. Thank you very much. So that brings us to an end.